Hello guys, welcome back to another live stream. And today we are going to talk about the pharmacodynamics. So let's begin. So what is pharmacodynamics? It denotes the action of drug on biology systems, including receptor interaction, dose response phenomenon, and mechanism of therapeutic and toxic actions. How a drug effect occurs. So targets of drug action include cell membrane receptors, enzymes, transport systems, intracellular processes, ribosomes, mitochondrial nucleus, enzymes, and extracellular processes, including the antihelminthic drugs. So, are there drugs that act without being bound to any of the tissue constituent? Yes or no? So, the answer is yes. And these are osmotic diuretics, osmotic uh, purgatives, antacids, and heavy metal chelating agents. So many drugs inhibit in-patient ACE inhibitors in microcells, penicillin, and in cancer cells 5FU and 6MP. Okay. Most drugs act through receptors. Receptors. So, a drug receptor is the macromolecular component of a cell with which a drug interacts to produce a response, usually a protein. Okay. Drug receptor is the molecular component of the drug with which the drug interacts to bring about their effects. Most receptors are proteins that are responsible for transducing extracellular signals from the intercellular responses. Okay. So, receptors are recognition site, a specific region of the receptor macromolecule to which the drug binds and has a relatively high and selective affinity for the drug molecule. Inert binding molecule or site, a molecule to which a drug may bind without changing any function. Okay. So, effectors, second messenger, are molecules that translate the drug receptor interaction into a change in the cellular activity or cellular response, often a channel or enzyme molecule. The best examples of effectors are enzymes like adenyl cyclase, a tyrosine kinase effector that is a part of receptor molecule, ionocetal type of IP3 calcium ions. Okay, so pharmacodynamics drug receptor interaction. So drug receptor complex, it is called affinity. Okay, effect, and this drug receptor complex, it forms a therapeutic effect. Then some terminology regarding the drug interaction are affinity, efficacy, potential, and ligand. So affinity is a measure of a propensity of a drug to bind receptor, the attractiveness of drug and receptor. Okay, efficacy is the potential maximum therapeutic response that a drug can produce, like maximum therapeutic response that a drug can produce is called efficacy. Okay, and affinity is basically the attractiveness of drug to the receptor, and potency is the maximum amount of drug needed to produce an effect. So characteristics of receptors, specificity, selectivity of response, and sensitivity. So, how drug receptor complexes are transformed to effects. So, by the five signaling mechanisms. So, signaling mechanisms, once an agonist drug has bound to its receptor, some effector mechanism is activated. For the largest group of drug receptor interaction, the drug is present in the in the extracellular space, while the effector mechanism resides inside the cell and modifies some intercellular processes by by transmembrane signaling. Okay, so there are five major signaling mechanisms are recognized. First is the receptor. So first is the receptor that are intracellular. Example, steroid steroid receptors, and second is the receptors located on membrane spanning enzymes or transmembrane enzymes linked receptors. So There are five. First is the lipid soluble chemical agent crosses the plasma membrane and acts as an intercellular receptor, which may be an enzyme or a regulator of gene transmission. Okay. Second type is the signal binds to the extracellular domain of a transmembrane protein, thereby activating an enzymatic activity of its cytoplasmic domain. Third is the signal binds to the extracellular domain of a transmembrane receptor bound to a separate protein, tyrosine kinase, which it activates. Fourth is the signal bind to and directly regulate the opening of ion channel, example, cholinergic. Five is the signals binds to a cell surface receptor linked to an effector enzyme by a G protein. Okay, so I'll summarize this information for you. That's it. Five major mechanisms. First is the intracellular receptors. Second is the receptors located in the membrane. Example is the transmembrane receptor for insulin. And third is the Jack-Stat pathway. Fourth is the transmembrane channel, ion channel. And fifth is the G protein, most abundant alpha and beta adrenoreceptors. See. So, example, third is a receptor located on membrane spanning molecule that bind separate intercellular tyrosine kinase molecule insulin receptors. Receptors located on membrane ion channels. Example, GABA receptors for benzodiazepines, nicotine receptors for acetylcholine, and sodium channels for local anesthetics. And receptors linked to the effector G protein or G protein coupled receptors. For example, alpha and beta adrenoreceptors. G protein coupled receptors are the most abundant type of receptors, and their activation account for the action of most therapeutic agents. Important processes mediated by G protein coupled receptors include the neurotransmission, olfaction, and vision. Ligand, molecules that bind to receptor. So classification of ligands. So there are three types of ligands: agonist, partial agonist, and antagonist. So in this agonist, we have also three types: pharmacological, physiological, and chemical agonist, partial agonist, and same goes for the antagonist. So pharmacological antagonist competitive, surmountable, and non-competitive. So agonist. Agonist a drug that activates its receptor upon binding. A full agonist is a drug capable of fully activating the effector system, or drug produces a maximum biological response when it binds to the receptor. In general, a full agonist has a strong affinity for its receptor, and a good efficacy. Efficacy. What is efficacy? Efficacy is basically the minimum amount of drug that is required for the therapeutic for the therapeutic effect, right? Or am I right? Or am I wrong? uh Shit. Okay. I told the definition of potency. Okay, so efficacy, potential maximum therapeutic response that a drug can produce. Maximum therapeutic response that a drug can produce. Efficacy. ठीक ठीक है. So partial agonist, a drug that binds to its receptor but produces a smaller effect at full dosage than the full agonist. That is, the partial agonist have efficacy greater than zero but less than that of full agonist. ठीक है. A unique feature of these drugs is that in the presence of full agonist, the partial agonist acts as an inhibitor. Naloxone is in the presence of morphine. Okay, so naloxone is the partial agonist of the morphine. Like in the absence of morphine, it acts as an agonist, and produces the effect that are similar to morphine. But the thing is that when the morphine is present, it acts as a antagonist, inhibitor, kind of. So, agonist, drugs that cause a response, drugs that interact with and activate receptors, they possess both affinity and efficacy. Affinity, what is affinity? It is basically the attractiveness to the receptor, and efficacy is basically the maximum therapeutic response that the drug can produce. Okay, so full agonist, an agonist with maximal efficacy response has affinity plus intrinsic activity. Partial agonist, an agonist with less than maximal efficacy and has affinity and less intrinsic activity. Antagonist. If the drug receptor binding results in the inhibition of receptor, the drug is termed an antagonist. That is, antagonist are drugs that decrease or oppose the action of another drug or endogenous ligand. An antagonist has many effects if an agonist is not present here. Oh, okay. An antagonist has no effect if an agonist is not present here. So many antagonists act on the identical receptor macromolecule as the agonist. Antagonist here. So जब भी अपना देख so एंटागनिस्ट का काम क्या है कि अगोनिस्ट को ऑपोज करना, लेकिन जब एगोनिस्ट नहीं रहेगा अपने बॉडी का, तो फिर एंटागनिस्ट का काम क्या होगा? कुछ भी नहीं होगा। तो फिर अपन ने वेस्ट किया एंटागनिस्ट। एंटागनिस्ट इंटरेक्ट विद द रिसेप्टर बट डू नॉट चेंज द रिसेप्टर। ठीक है, do not change they do not change the receptor. Okay, ठीक है, have affinity but no efficacy. No efficacy. Like they can't produce any therapeutic effect, maximum therapeutic effect. Block the action of other drug, effect only other drugs. Pharmacologic antagonist, a drug that binds without activating its receptor and thereby prevents activation by an agonist. ठीक है. And competitive antagonist, if both the antagonist and agonist bind to the same set of the receptor, they are said to be competitive. The competitive antagonist will prevent an agonist from binding to its receptor and maintain the receptor in its inactive conformation state. For example, the antihypertensive drug tirazosine competes with the endogenous ligands norepinephrine at alpha-1 adrenoceptors, thus decreasing vascular smooth muscle tone and reducing blood pressure, phentolamine and adrenaline. Thus, they are thus competitive antagonists that bind to the agonist receptor site in a reversible way without activating the effector system for that receptor. In the presence of a competitive antagonist, the maximal response of the agonist can be obtained by increasing the amount of agonist administered. So, pharmacology antagonists can be overcome by increasing the concentration of agonist. So, irreversible non-competitive antagonist. A pharmacologic antagonist that cannot be overcome by increasing agonist concentration. In the presence of non-competitive antagonist, a maximal response is not observed even with the increasing dose of agonist. Example: indirect acting cholinomimetics or irreversible inhibitors of acetylcholine, xarine, zoma, and military gas. Physiologic functional antagonist, a drug that counters the effects of another by binding to a different receptor and causing opposing effects. A familiar example of a physiology antagonist is the antagonism of the bronchoconstrictional action by of histamine receptor by epinephrine bronchodilator action mediated by the beta adrenergic receptor. So फिजियोलॉजी का एकदम क्या है हिस्टामाइन जो है वो एक अपना एगेनिस्ट है for causing the broncho constriction. But the thing is that this epinephrine it blocks the this site for the histamine and causes the bronchodilation. Chemical antagonist, a drug that counters the effect of another by binding the agonist drug, not the receptor. A chemical antagonist indirectly interacts directly with the drug. For instance, pralidoxim combines with the phosphorus in organophosphate, cholinesterase inhibitor, and protamine sulfate is a chemical antagonist for मतलब ये क्या करते हैं कि ये ड्रग्स क्या करते हैं कि ये ड्रग्स अपने अपने अपना जो पोटेंट ड्रग है जो अपना जो विच विल प्रोड्यूस द थेरेप्यूटिक फील्ड उसको जाते हैं और उसका केमिकल स्ट्रक्चर चेंज कर देते हैं तो फिर उसके वजह से क्या होता है कि इट कैन बाइंड टू द रिसेप्टर ऑफ इट्स काइंड LSD agonist or antagonist. A drug that binds to a receptor molecule without interfering with normal agonist binding, but alter the response to the normal agonist. Thus, if the antagonist binds to a site other than where the agonist binds, the interaction is LSD. Thus, an agonist is defined as an agent that bind that can bind to a receptor and elicit a biological response. Another receptor regulation. So, receptor regulation. So, receptors are dynamically regulated in number and sensitivity. Changes can occur over short time, minutes, and longer period days. Repeated or continuous administration of an agonist or an antagonist may lead to changes in the responsiveness of the receptor. Frequent or continuous exposure to agonist often result in short-term diminution of the receptor response, sometimes called tachyphylaxis. The receptor becomes desensitized to the action of drug. Long-term regulation in receptor number. Down regulation may also occur in response to continuous exposure to agonists. The opposite change, upregulation in induction in receptor number occurs when receptor activation is blocked for prolonged period, usually several days, by pharmacologic antagonism or by denervation. समझे नहीं? Hmm. Continuous exposure to antagonist causes the upregulation and continuous exposure to agonist causes downregulation of the receptors. Okay. So now response relationship. So the concentration of the drug at the site of the action controls the effect. The magnitude of the drug effect depends on the drug concentration at the receptor site, which in turn is determined by both the drug of both by the dose of the drug administered and by the drugs and and okay वो दोबारा पढ़ेंगे. The magnitude of the drug effect depends on the drug concentration at the receptor site, which in turn is determined by both the dose of the drug administered and by the drug's pharmacokinetic profile, like rate of absorption, distribution, metabolism, and elimination. Theories of relationship between binding and drug. बस बस नहीं. Okay, guys, finally, it's finished. Thank you. Bye bye.